Good afternoon from southern New Hampshire. It's 1400 on the East Coast, 1800 GMT, and 1530 Newfoundland time. This is PFG Live. Brian checking in. He says hello from Northeast Ohio with 81 degrees. Here in southern New Hampshire, it is currently 84 degrees with the rumbles of thunderstorms heard in the distance. We've got DBX checking in on Discord. He is still in Japan. And he says it's 83 degrees. Nope, that's not you. DBX is not in Japan. You're in the Japan section of Brooklyn. So DBX is checking in from Rockland County. 83 Fahrenheit and sunny with a 56 degree relative humidity. That's not bad. We do have thunderstorms up north here, so you might want to check that. Let's see. WidgetWorks Manufacturing is checking in. Welcome aboard, sir. You are reporting 24 degrees Celsius and sunny, 46 degrees relative humidity in the Edmonton of the Alberta. Welcome, sir. Nice to see you. Oh, really? You had thunderstorms last night? Yeah, it's a little, it's going to be a little crazy today. Let's see, who else is checking in? I think we've got everybody covered. I started a few minutes later than normal. I'll give you my excuses in a second, but everything is going just according to plan otherwise. CJ Stevens has joined us. 86 and partly sunny and humid in the east of Tennessee. Almost is here with, drum roll please, 100F in the Phoenix. Welcome, sir. Nice to hear you. If you haven't been following, Almost is like scraping up a lot of work. He's scraping. Get it? What else? Protium is... he's checking in on Discord, 91 and 27% in Tucson. So Tucson is a little nicer, I guess. Robert Simpson is here, 80 degrees and partly cloudy near Detroit. How near? Like, if you went out your front door and you went to the heart of the city, how far would you have to go? I'm just curious. Yeah. Yeah, Protium says it's a lot less pavement and thermal mass than Phoenix. I believe that. Excellent. Well, it's funny because I joke about my wife grew up north of New York City in Larchmont, which I'm sure DBX is familiar with. And I always called that the country, and that drove some people crazy. But it's kind of the country. 3/4. So he says, Robert Simpson says 3/4 of a mile north of the border of Detroit. Downtown is about 10 miles away. So yeah, that's pretty cool. I guess if I drove to Boston, it's a lot more than 10 miles. So you're closer in. So we have some stuff to talk about today. Nothing earth-shattering. Some progress has been made on several fronts, and we can go over that. Hey, Machine New Zealand is here. Good morning. And by the way, as soon as you checked in, it started pouring here in southern New Hampshire. I'm sure it had everything to do with it. So give us about 10 minutes worth, Machine NZ, and then turn the valve off, would you? It's starting to rain. You might hear it in the background. So speaking of hearing it in the background, we're using a new microphone today, and just getting the hang of it, just getting it sorted out. DBX, who is a former audio engineer, is helping me a little bit get it sorted out. But it's new, so it might be a different sound, and that explains a lot. So yeah, many things happened today, one of which happened literally in the last couple of hours, and we'll talk about that. So, nice to see you guys. If anybody has any interesting news, feel free to put it in the chat. We'll try to work it in. Let's see. We've been talking for for weeks about this relative humidity sensing, and I think we're bringing it in for a landing. One of the things we've discovered is that our round $3 hygrometers that we're buying off of Amazon they're inaccurate. So let me clarify that. My friend Doug, who may check in today, may not, he's done some very extensive testing on these things, like serious nerd out testing. And what we've found is that they are accurate around 50% and up. So 50% relative humidity and up, they're not bad, okay? But 50% relative humidity and down, they start to get bad again. Joel L's checking in. Good morning, sir. Nice to see you. So you get what you pay for with your $3 hygrometer. Now we've ripped them apart and analyzed how they work. I don't have one here to show you, but you know what they look like. The relative humidity sensor in the $3 hygrometers is basically the same structure as you would have for a conductive, those rubberized conductive buttons that you push on devices. Frequently, they will land on the circuit board on a pattern that looks like interdigitated conductors. And when you push down on the button, it connects the conductors. So the mechanism for the $3 hygrometers is literally measuring the resistance between these printed interdigitated conductors. There's a ceramic substrate, and there looks to be a carbon-loaded... oh, wait. Carl is here. Carl, welcome aboard. All rise, please. Okay, be seated. So you have these carbon ink printed interdigitated conductors, and then the circuitry is trying to measure conductivity between them. So the presence of moisture effectively on the surface of this ceramic substrate is causing a current path. So the resistance goes down when there's moisture, and it goes up when it's dry. So what do you have? You've got, in the very dry conditions, you have a very high resistance, very little current flowing, and you're asking this pretty cheapo circuit to make a measurement at extremely low currents. And what you end up with is a bad number. It's very hard to do. So this is why that sensor is crashing. This is one of the reasons that sensor is crashing at low humidity levels, which we care about. So along comes the Sensorion board, which we've been touting. I didn't discover it. Doug discovered it, and he gave me one of the 3 series, and then I bought off of DigiKey. I bought the 4 series. Here it is. If you're watching on video, there's the little board. Now, by the way, this little board, well, first of all, it's $30. I think you knew that. Carl, it's a remarkable coincidence because I played bass for Quantitative Creepage back in the 80s. So the little board is $30, but it's got a battery built on it. It's got a wonderful display. It's got a Bluetooth low energy interface. It'll switch between dew point and relative humidity. It does all sorts of cool things. But and then in our testing, if you've been around following this, you know that in our testing it's been just stunningly good. Now, Doug tested these things from first principles. So he had a sealed container, and he literally titrated water into the container. So he was doing calculations of the relative humidity from first principles and plotting the output of the hygrometer against the calculated values. I will tell you that the curve, I don't have them to show you, but the curve for the Sensorion board was a dead straight line. It was gorgeous. Right down to zero, or close to zero. And then the curve for the $3 hygrometer didn't even start recording until above 10%. I was third base, Carl. I was the third base. I can't lie. That wasn't that good. So anyway, we discovered that this sucker is awesome. So I did a little research. I wanted to know how this Sensorion sensor works. Now, the sensor itself, let's see if I can get you a picture of this, because I took a picture of it for you today. Let's see if you're watching on the video. There it is. So it's a little chip on board. They cut a slot around the chip so there's no mechanical stresses on this thing. And then there's a little window leading to an integrated circuit, it seems. And that's all we know. Well, I did find a little bit of information from Sensorion on their website. Here it is, okay? And allow me to give you a dramatic reading. It says, Sensorion's relative humidity sensors are based on a capacitive measuring principle. The sensor element consists of a capacitor whose dielectric is made of a polymer. This absorbs or releases water in proportion to the relative ambient humidity. The resulting change in the dielectric constant alters the capacitance of the capacitor, which can be measured with an electronic circuit. The temperature measurement is made possible by bipolar transistors. Listen, that last line, guys, you could have left that out. We didn't need that last one. All right, so let me explain what's going on. First of all, if you're not an electrical engineering type or a ham radio operator or a hacker of electronic circuits, you might not even know what a capacitor is. So if I take two metal plates, two parallel plates, and I put them in relative proximity to each other, they form an electronic component we call a capacitor. And if you apply a voltage to it, it will store an electric charge on the plates. One side has a positive charge, one side has a negative charge. Oh, DBX. DBX says he played bass for the bipolar transistors back in the 80s. We might have been on stage together or incarcerated together. I'm not sure which. So the amount of charge we can store between those plates is called capacitance. And that's what a capacitor is. Now, if you've ever shuffled your feet across a wool carpet or something and then touched a cold water faucet and got a zap, a static electricity zap, you were the capacitor. You stored charge. Anyway, let's go back to our thought experiment with these two parallel plates. If you think about it, there's air between those plates, or there's vacuum, if you want to be, really theoretical. And we call that the dielectric. So when there's nothing between the plates, we say it has an air dielectric, or it has a dielectric constant of a relative dielectric constant of 1. But if you stick some sort of spooge between the plates, you can increase the capacitor value, and that dielectric can have a higher value. So if you're an audio guy and you look inside your amplifier and you see these little cans that are capacitors, and they have they're marked 100 microfarads or whatever, they have stuff in them that has a relative dielectric constant that multiplies the effect of the capacitor. So if I have two parallel plates and I want to make a bigger capacitance, I can do it two ways. Number one, I can move the plates closer. I can make the plates bigger, or I could put the spooge between them. So now let's translate that knowledge to our sensor. So they give us a helpful little picture in the little write-up that I read you. And they have two plates that are next to each other on the surface of an integrated circuit. And then they have a polymer, which is another way of saying a plastic, some sort of material, on top of those two plates, and the electric field lines between them goes through the polymer. Yeah, Robert Simpson says he has radial electrolytics. You know, there's a dermatologist that I know that I could send you to who could take care of your radial electrolytics. I'm so sorry. So they made a capacitor, except the dielectric between the plates is exposed to the air. And if water is in the dielectric constant goes up and the capacitance goes up. If there's no water in the polymer, Robert Simpson's radial electrolytics are oozing electrolytics. I'll leave that one for Chris. So if you make an electronic circuit that uses that capacitor, for example, in what we call an oscillator, okay, so the thing is sitting there switching between two values, boop, 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 and it depends in part on the capacitor value. The frequency of that oscillator can go up or it can go down based on the water content of the polymer. Here's the thing. If you have no water in the polymer, it's still a capacitor. And if you have a ton of water in the polymer, the capacitance goes up and it's going to saturate at some pretty high level. But it's effective throughout the range. And that's what we're seeing, is that this thing works from 0 up to high values. So that was a long way to say that this is a pretty cool way of making a sensor. And by the way, for those of you playing at home, if you're following on your score sheets, the dielectric constant, the relative dielectric constant of water is about 80. In other words, it's 80 times higher than air. So doing things with capacitance sounds like a pretty good deal. So long story short, they're making bank on this capacitor-based sensor, and it works. It works phenomenally well. Now, here's the rest of the story. You'll notice in the picture on your screen, and if not, I'll describe it to you. We have a little square package. In the middle is a hole leading down to the chip, and there's only 4 leads, okay? This thing has the sensor circuitry plus a digital circuit that talks, for you digital guys, it talks I²C, which is just a format that's really easy to interface to. So there's only 4 pins on this thing. There's plus voltage, ground, and then 2 pins for the I²C interface, and you're done. In fact, if you like playing with microcontrollers and you're familiar with Adafruit, a great website, great manufacturer of little blivets, they have a Sensorion chip based blivet. Actually, they have a couple of them for their line of what are they called? Feathers. They call their little microprocessors feathers. So you can go check that out, and you can play around yourself. So after it comes out of the chip, it's just a microprocessor. Now, here's the weird thing about this Sensorion board, okay? Again, I'm going to show this to you on the video. In this corner of the Sensorion board is this little tiny daughter board. I mean, really tiny, like maybe 1/4 of an inch by 1/2 of an inch. And at first glance, you see this little wire coming out of it to a chip antenna. That's a bad word, by the way. And that's your Bluetooth Low Energy module, but it's also the processor for the whole thing. So the rest of the board space is taken up by the battery and the display. I mean, this is crazy how tiny the tech is in this. So anyway, very useful, $30. It's designed as an evaluation board for engineers to convince them to design the Sensorion sensor into their product. However, it also does a great job of serving as a reference standard for relative humidity. So my philosophy now is simple. It's if you want to keep buying the $3 hygrometers, use this as your reference to check them against. If you decide they're junk, throw them out. If you decide they're good enough for what you're doing, continue using them, having proven to yourself what they're good at. Okay, so that's the Sensorion evaluation board story, and that's the board. So having said all that, I wanted to make this thing a little more user-friendly, and if you've been following on Instagram, you'll know that I made this housing for this board, and it took a few iterations. This is what we call P7, or the 7th iteration of the prototypes. And the board just drops into the bottom, and the top just snaps over it. I'm doing it live here, folks. Okay? And there you go. So this makes it really kind of nice. I have placed the STL files for this housing on my links page at pfg.gg/links, including a pointer to the Sensorion board on DigiKey, hashtag not sponsored. So what I'm holding in my hands right now is, a few bucks for the PLA. Well, it's not even a few bucks for the PLA, and then $30 for the board. And we have us a really nice, like plus or minus 1.8% relative humidity sensor. Now, I'll wrap it up by saying that the sensor on this board is their SHT40 sensor, and they go up to SHT45, which is the most expensive. Like, it goes from $1 or $2 to like $4 or $5. But the higher one, the 45, is more accurate, if you can believe it. And it goes down. It has higher accuracy at the low end. So we don't have a board available to use that quite yet. But there you go. That's the Sensorion sensor. Now, if there are enough people that want these things, just like you're seeing in my hand, in the case, okay, that I designed, who don't want a 3D printed case and don't want to figure out how to order from DigiKey, and you send me a message and say, I want one, we'll put these together. I'll charge just enough to cover my costs, and then we'll make them available. How's that? Okay? So you guys let me know, but I believe now we have a reference standard, and we're good. So if you have any questions about that whole project, let me know. But I think that sort of wraps it up. And I've printed up, I have 4 more of these guys coming, and I've printed up cases for them. So Almost Machining says the sensor is a little better than a DHT22, which I'm unfamiliar with. But like I said, I was depending on the expertise of others to find that Sensorion sensor. So if there's something even better, I'm interested to know. But we're kind of done as far as I'm concerned. Okay, Carl's in for one. I'll let you know, Carl. In fact, I better start a list so it doesn't get away from me here. Look for the pen. RH sensors. Carl's in. Okay. Yeah, you could just tell me. You could just tell me in the chat if you want one, and I'll make a list, and I'll let you guys know on Instagram. So that's the story. In other news, so Robert Simpson says you just need cases. So I can also make you the cases if you're not into 3D printing. We could do that too. So cases only, huh? All right. So that's Robert Simpson. Gotcha on the list. We'll take care of you, buddy. So in other okay, good. So in other news, we started evaluating the balancing stand twist and the taper collet, what we're calling the taper collet in the balancing stand. So the taper collet goes into the taper of the grinding wheel adapter, and that locks that to the arbor in a way such that the concentricity is low and the perpendicularity is high. Gotcha, Joel. So we started making some measurements, and they're pretty impressive, what we're learning here so far. In fact, the photo, let me get you this picture up on the screen. The photo of in the thumbnail shows the measurement setup. So I grabbed a grinding wheel hub, took off the nut. Some would say that the nut's still here. And I literally, I tried clamping it, but that was less reliable. I super glued it to a V-block and had a nice little setup so that I could put the taper collet into the adapter hub and put the rod in and then measure how it changed position. And in the initial measurements we were seeing on this unit, 7 10,000ths of an inch of total indicated run out. Now, you got to be careful. It's not really total indicated run out because we're only measuring it at 4 reference points. So, but you understand the total difference between any two of those measurements was 7 10,000ths of an inch. So from the standpoint of balancing, that's pretty good. It is not perfect, and it is not zero. But if you're running along on your small grinder and you're not balancing wheels, this is going to make all the difference in the world. So I'm very happy about that. So what we're going to do is for the first 20 BS8s that go out the door, we're going to make the measurements and include a data sheet with each one of them. So there's 2 things that are going to happen. Number 1, we're going to get data, statistical data, so that we understand where we're at. And number 2, you're going to get the data of your unit as it goes out the door. After the first 20 units, we won't be measuring anymore. We'll be, trusting the data. But again, this is a balancing situation. This is not a, we're not building machine ways. We're not, doing any of that stuff. So I'm really happy about the results. Also, I don't think I published the numbers, but we also measured the twist, so the non-parallelism of the 2 rods in the balancing stand housing, and that was similarly excellent. In fact, I'll tell you a very funny story. I set out the aluminum based balancing stand that you've seen in pictures before, and I put it on the granite surface plate, and I got it all jigged up, and I started measuring the twist of it. And the twist of the BS8 balancing stand was superior to the one that I've been depending on now for literally years. So I am not super worried about the twist, although it came out great. I was more concerned about this taper collet, and now it's completely viable. So we're able to get this job done and get it out the door for under $200. That makes me very, very happy. And it should make you happy too, because you can now have balanced wheels. The website for the balancing stand is bal.gg. That always existed, but it pointed to the balancing rings, which is rin.gg, and now it has its own page. The page is just the skeletal beginnings, but we'll have more. For example, we'll have this information on that page. So, pretty happy about measuring the run out on the taper collet, and that should put a bunch of minds at ease. So that's the story on the taper collet. Very happy about that. You can order the model number BS8, which has a secret message to you, right on the website. And if you're one of the first 20, you will get the data sheet. Okay? So that's the rest of the news. So far, what we've talked about today, there's 2 examples of 3D printing being used in appropriate, in useful ways. The latter being the most surprising. But I'm pretty excited about that. So one of the subtitles of today's episode was, if it's crazy and it works, then it's not crazy. So that applies to the taper collet. But wait, there's more. I bet you thought that was the only crazy, not crazy thing. But literally relatively early this morning, I get a message from one of our friends at Saunders Machine Works, Mr. John Saunders. And he had mentioned, if you listen to his podcast, which I strongly recommend, called The Business of Machining, he was talking about the training course that he teaches. And one of the aspects of a training course is you have a bunch of people that are training. And they don't necessarily know what they're doing. And they break Haimer tips on their Haimer probes more often than you would if you were just doing shop work. In fact, a while back, John made these signs which you were supposed to put up somewhere and use with a dry erase marker, that it has been, how many days since I last broke a Haimer tip. That was the running joke. And that's been a running joke for years. It's hysterical. So he came up with the idea of printing using SLA printing or resin printing, these Haimer tips that are not necessarily going to be the most accurate, but they will be good replacements for training in case they get broken. So this morning, John shoots me the okay, we'll take a minor detour here. Almost says the mass shift at 1,000th of an inch wouldn't be enough to matter at home. 7.0007% of the total distance, not mass, but very low percentage of offset to wheel diameter at 7 inches. Yeah, there's an analysis that I need to go through, and I'll get it on video of this whole thing. There's a whole topic that needs to be addressed called compound pendulums and moment arms that will quantify what it means to have a 10,000th of an inch of run out on your grinding wheel, right? And it's not really a 10,000th of an inch of run out, it's a 10,000th of an inch of moment arm. We have to go through all of that. There's an interesting calculation beyond the scope of this podcast, but I'll get it. I'm going to get that done. I'll get it on paper, and then we could talk about it. I got to get it so that I could explain it. Albert Einstein was quoted as saying, if you can't explain something simply, you don't understand it. And I adhere to that. So we'll get that sorted out almost. Anyway, so this morning we're messaging back and forth, John and I said, didn't you want something SLA printed? And he said, yes. So we started talking about it. We ended up on a Zoom call, and he sent me the files, and I said, I can do that. So I added a couple of twists to his idea, and here in my hot little hands, I have the very first 3D printed Haimer tip. And there it is. So if you use a Haimer, you'll recognize that shape. And there's the ball and everything. Now, the thing I added, if you look, you'll see these two cross-drilled holes. So in the top of this thing, there's actually a threaded hole. That's going to be very hard to see. And there was a clearance hole that goes most of the way through. And when you resin print something, you don't want what we call a cup. You don't want a place for resin to gather in a spot. You want it to be able to drain out. So that was the first idea with the crossed drilled holes, but also you want it to break if it hits something hard. So that's another possible function of these cross drilled holes. Anyway, this thing came off the printer. This is literally the first one, and we have some head scratching to do. This is what it looks like. Sorry, podcast guys. This is what it looks like when it literally comes off the printer. There's a bunch of little support structure. And when you separate an SLA print from its support structure, you get these little blemishes on the part. And what you do in resin printing is most of the DBX says, now do the long Haimer tip. You would be very surprised at what SLA printing will do. We could probably do it. So half of SLA printing is managing where those supports are going so that either you can clean up the little blemishes or they don't matter. So, I had all of 10 minutes to do this, and we got it to a pretty good place. So I'll be shipping this off to John, and I'll say, "Is this what you mean?" And we'll see what happens. But I'm pretty happy with the first prints. I mean, the detail above where the support's attached, the detail is just stunning. And then for those of you playing at home, this is printed on Formlabs Gray version 4 resin, which is also known as baby's first resin. So it's the resin that is real useful for high detail, but you wouldn't use it for mechanical strength or rigidity typically. So it will break, which is what you actually want. So we'll look forward to doing this. So I'm going to get these into the mail to John and let him evaluate them. Okay, Chris, welcome back. He says, I haven't tuned in for quite some time. What's your updated opinion of the Bamboo? Any customer service experience yet? Hey, Machine New Zealand, have a great day at work. You're awesome. Once again, go to work smiling. Everybody will be completely perplexed. We'll see you later. So what's my updated opinion of the Bamboo? Any customer service experience yet? I have had a little customer service experience. My customer service experience has been generally excellent. There's one story that's a little weird, and I'm not ready to talk about it yet. I know I alluded to it last week, and I thought I would have something to tell you, but I'm kind of still waiting. It's nothing major. Don't worry. It's nothing. But as far as like when the first printer came in with a defect, they jumped on it. They took care of it, and they got me my replacement, and I got my refund, and everything was cool. So my experience with that was excellent. From a customer service standpoint, I would give that an A+. The printer itself, all of them, have been performing shockingly well. When I was printing, by the way, and this has nothing to do with the quality of the printer, but when I was printing the cases for the, come on, you could focus. You've done it before. When I was, here's P5. This is prototype version 5 on the video. And when I got these off of the plate, the smooth plate, the so-called PLA plate, they were really on there. And when they came off, we got some whitening in the blue PLA. So that was like sticking too much. So I started using Windex on the cool PLA plate for this product, and the whitening disappeared. So now they're, again, same process. Now they're just gorgeous. You could focus. There we go. See that? Just beautiful. So quality-wise, performance-wise, no problems. You still have to use the tool, right? And you could use the tool well, or you could screw up. So, yeah, it's still a very positive experience. Let's put things in perspective, okay? Can we pop up 10,000 feet here? I just showed you a part, right? This is the SLA part, right? That printer is, I think, it's on the order of $4,000. It's like $3,600, $4,000 for the Formlabs 3 Plus. And the Bamboo printer is under $1,500. So I think from a value standpoint, it's an excellent value, and it's doing a great job. By the way, I think the same thing about the Formlabs printer. I could say all the same things. Great tool and great customer service. So I hope I answered your question, Chris. It's been very positive. I find other stories of other people, right, that are having some issues. And let me talk to that for a second. The internet is a dangerous place because you are going to see the outliers. You're going to see the 1% things. Why? Because that's what's interesting. So you read about somebody having trouble with bamboo, and then you read about another person having trouble with bamboo, and then you read about another person that's having trouble with bamboo, and all of a sudden you say, oh my gosh, people are having trouble with it. So this morning, I'm also in a internet group on Facebook for people who own Ford F-150 Lightnings. And I thought this was pretty brilliant. Somebody posted a poll, and you see this traffic going by about, I'm having trouble with my thing, and my battery is, I'm having battery problems, and I had to go into the shop for 3 months, and they're still working on my battery. So you get this impression that there are battery problems. So somebody this morning had posted a poll, which was very smart, of, there was 4 different things you can vote on. I had some battery problems, major battery problems, blah, 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 and I had no battery problems. Well, you should have seen the bar graph of the results of this poll. It was the number of people that were having trouble were tiny, but those are the ones you hear about. Okay, so the same thing happens with the Bamboo printer. It's the exact same thing. You hear about all these stories. Well, everybody that's happy with them, they're not making stories for you to hear. So I'm happy to say that I'm having a great time with the product. No issues. Okay. Yeah. They just updated software. I thought it was all improvements. It's fine. Hashtag not sponsored. Seriously, not sponsored. Hermit Shed, welcome, sir. You're a little late, but we'll forgive you. 78 and sunny in Zeeland, Michigan. Not to be confused with New Zealand. See, a whole bunch of people left Michigan and went somewhere and built an island called New Zealand. Do I have that right? Hermit Shed? Is that correct? I believe that's correct. Good thing Machine NZ left for work, because otherwise he'd be throwing things at me. So that's the story on the bamboo. It's a tool now, and we're using it, and it's awesome. Is it really a lot faster? Okay, so here, bottom line, I can say this without any compunctions. It's, in all cases, in my experience, has been at least double the speed of my Prusas. Now, those of you that have bamboos would say that's not a terribly high bar, right? But there was some theoretical, before I pushed the button and I bought it. Chipload, are you late? Do you have a clock? You are late. Go sit in the back. We still love you. Double the speed, full stop. There was indications before I pushed the button to buy the printer that it was going to be 4 times faster. This was in discussions with John Saunders. We were having some, I sent him some models, and he sliced them for me, and we started looking at the initial numbers, and it was looking like 4x. And then after the reality set in, and we started doing all the real things, and I actually started making trays. That's what it was on. It was an honest 2x, like solid 2x, and you could make the argument that it was closer to 3, but that's my answer. Double the speed. Hermit Shed says, not sure that New Zealand is newer than Zealand. I have a note from my mom for being tardy. Totally acceptable, but do you have cookies? Did you bring cookies? Because, a note, nobody could eat a note. Test Room 2003 says, good morning from, Oostkapelle, Holland, the province Zealand. Oh my gosh. We've done it. We've hit the Trinity. We have New Zealand having checked in this morning. We have Zeeland, Michigan having checked in. And now the province of Zealand in Holland has checked in. You guys have done it. You win the internet. I'm dropping the mic. I'm actually not dropping the mic. Welcome aboard. Nice to see you, Test Room 2003. That's you're a new name here, and you are completely welcome. And Test Room reports 19 degrees Celsius with 72% relative velocity. I think you mean RH, but it's totally cool. Well, welcome, sir. Welcome aboard. So, did I do it? Did I answer your questions about the bamboo? This whole thing with the bamboos is slowly tapering to normality, right? And we're still waiting for Joseph to show up with massive improvements. We still love you, Joseph. You're just a little slow. So let's see. I think we hit all the high points here. Evils says only 28% until a full recreational vehicle. Oh, I see. So you're claiming that Test Room 2003 has 72% of a recreational vehicle. I'll allow it. So, any other questions? Pop them in there, and we'll address it. We're here for you. I'm not here for my health. Believe me. What else could we talk about today? We've talked about 3D printing in kind of 3 different ways. Also running in the shop this week, if you've been on Instagram. Evils says, greetings from Ghent with 23 Celsius and 55% indoors. Very nice. Robert Simpson says, almost 100% sold on a bamboo. What are you running now, sir? Do you have a 3D printer? We'll see if we can give you some advice and counsel. I'll tell you what, if you've been running a, kind of slowish, modest 3D printer, the thing will blow your socks off the first time it makes a print. Nothing right now. So that raises the question of is it a good choice for somebody buying their first 3D printer? And the answer is yeah. Although you should have a mentor, right, or multiple mentors to cover the fundamentals, because the fundamentals are still the fundamentals. For example, something that Bamboo is doing wrong is the model that they include as a built-in model in their printer for a benchy. Okay, so if you guys are not familiar with what a benchy is, it's a little boat which has become the de facto standard for testing 3D printers. And it's called a benchy for benchmark. Okay? And if you try to print the benchy model built into the printer, it's way too fast, and I don't think it prints well, and the first layer is a little iffy. So if you download the benchy and you slice it the way you would normally slice it and print it, it takes 20% longer, 15% longer, and it comes out great. So that's a mistake they need to fix. And frankly, they might have fixed it on the last software release. I haven't checked. But that was a problem. They were really pushing it. Almost said, here I've been debating buying an Octoprint controller to replace your Arduinos, which have the $120 to resurrect your printers. My issue is I did not want printers to be my hobby, so it was sort of a no-brainer. Any printer that I could ignore for most of the time and have it do the right thing is great. See what you're doing right now, I don't want to do. So it's up to you. If you enjoy it, do it. Proteum, I will answer your question in a second. Bamboo X1, DBX says Bamboo X1 Carbon is his first, and he's been very pleased abusing this forum as a mentor. Totally cool. That's why we're here. So there you go. There's a vote from DBX. Chris says, I have no printer currently. Bamboo would be the first, and I like that it's plug and play. Less fiddling or tinkering. I'm an amateur. I think you won't be dissatisfied. I think you'll be fine. Really. Now, before the Bamboo existed, if you asked me what you should buy, I would have said a Prusa and get the kit. Because the act of building the kit shows you the guts and teaches you what's what and enables you to fix your own printer. That's all good things, okay? So you're not going to get that with the Bamboo because there are no 3D printed parts in the 3D printer, whereas in the Prusa, there's lots of 3D printed parts in the 3D printer. Two completely different approaches. Each one has its value. Almost says, I don't mind tinkering. It keeps costs down, but time spent is in years. I know. Art that makes art. Wes, welcome. He says he's printing his first fusion drawing right now. New skills unlocked. Excellent, buddy. Yeah, okay. I think we understand each other. So I think we can wrap up the 3D printing segment, and you know how I stand. And oh, by the way, a little commercial for our Discord. We have a Discord server. Information on how to get on the Discord server is in my links page at pfg.gg/links. If you're on the Discord server, we have a channel called 3D Printing. It is vigorous, and it has a very wide range of people between super experts and beginners, and happy to help you. Okay, so if you want another source of mentors, join the Discord server, and there you go. Robert Simpson is seeking recommendations for Linux slicers. You, sir, have exceeded the capacity of this podcast. Yeah, okay. You guys are off talking about Linux slicers, and that's totally fine. I'm just not going to get involved. A man's got to know his limitations. So, Proteum, you asked the question, what's with the new microphone? Okay, folks, I got a new microphone. So we were running on a HyperX microphone that costs about $140. I don't remember exactly what the price was, but it's something like that. And I decided I wanted to, upgrade the microphone. Why? Because this podcast slash YouTube live depends on good audio. Who wants to listen to crappy audio? So I bought a Heil PR40 microphone. It's not cheap. It's about a $400 and change microphone, and then you need an interface. So I have you can't see it, but it's called a Focusrite single channel interface that goes from an XLR connector. That's these fancy, in the world of fancy audio, the XLR connector is king. So it takes you from a proper audio XLR connector and gets you into the USB world. And when all was said and done, I started getting this thing set up, and I don't think we've finished fine tuning all the settings and everything. Here's the amazing thing. I think my total investment was about $700 versus $149. The HyperX microphone had digital conversion built in, so it went from audio to USB in the microphone. It had a gain control on the microphone. It had the fancy red light, which you guys had gotten used to, and it had a mute button for about $140 something, I think. The difference between that microphone and this microphone to the average listener is really hard to discern. DBX was helping me, and we did some comparisons. The video of mic comparisons is boring. I'm not going to publish it. And it's a small difference. I mean, it's a difference, and I like the new microphone. But my message to everybody who's looking for a good microphone is that HyperX microphone is really hard to beat. But I'm glad I got this one. When you take it out of the box, it weighs about 4 times what the other one weighs. It's a nice build. And Bob Heil, who started Heil Audio, and his sticker is right there, he is a ham radio operator, and I kind of knew of him because of that. But he also made, some has some serious accomplishments in the world of music. And he makes a good product. So this is an interesting product. It was recommended to me by, Robert Simpson, you're not wrong. I actually have a foam windscreen, which is not the same. I have one. So next podcast, I'll put it on and we'll experiment. I don't think I want to do it right now. Chris says, so there's a cheap used HyperX mic available then? No, so there's 2 others in my family using them, and so it'll be the spare. How's the directionality? Are you forced to sit directly in front of it? It has higher directionality than the HyperX, and I will now demonstrate it. As you can see, if I come around the side of the microphone, it's a pretty significant loss in gain, and then if I come back to the front, you can hear it picking up again. So it's sharper than the other one, and I'm being careful to be in the right place. Yes, the Scarlett, exactly. The Scarlett, what's it called? The Scarlett something? But yes, Solo. I think it's called the Scarlett Solo. And we could get into this on in the after show on Discord. How are we doing? Oh, we're coming up to the top of the hour. Yeah, DBX says direct recording might show the differences a little better than all of this digital stuff we're going through. It is a cardioid, yes. And don't get me started on cardioid patterns, because it really is only one cardioid pattern. Almost. Take care, buddy. Nice seeing you. Yeah. Okay, yeah, I want to talk about the Scarlet stuff. So I'll see you in the... We have a chat room on the Discord server called the After Party Roundtable, and that's where I'll be when we wrap this up. Okay. All right. I think the inbox is empty now. And it was great. Nice catching up with everyone. Looking forward to seeing you next Sunday. I don't see any impediments to doing this again. Pretty happy with all the successes. After the show today, I will probably be down in the shop and continuing on balancing rings, which is basically feeding the machine, and continuing on a set of 4-inch rectangular stones. We have about 7 sets that are in the pipeline. I got to get them finished. Carl, take care. Nice seeing you. Have an awesome rest of your day. We stopped raining and the sun came back out, so I trust you're having the same down in Rhode Island. Widget Works, take care. Get back to work, because we all need whatever it is you're doing. So thanks again for tuning in to the PFG Live, and we'll see everybody next week. Maybe we'll have reports for you on the experiments with the Haimer tip and other such things. Carl, take care. Joel L., have an awesome day. Chris, thanks for being there. Yes, we expect you to be more regular, sir. How else are you going to get that degree? You know what I'm saying? All right, guys, have an awesome day. And most importantly, don't get caught.